everyone, to another episode of Reliability BoomBox, proudly brought to you by Reliability Extranet Group of Companies. Welcome back, Seven. Nice to have you.
G'day, Wayne. How are you?
Yeah, I'm good.
Excellent.
Just sipping on a nice little lovely tea tonight, keeping you warm. So we're up to habit 3 of the 5 habits of extraordinary reliability engineering.
Yeah.
Exciting one, this one. I like this one. This is one of my favorite things to do, and that's ask questions. So,
yes,
questions, very important. So,
yes,
the last couple of weeks we spoke about habit 1 and habit 2, and now we're going into habit 3. So, check out on the links and follow up on that. Each of these are still standalone podcasts. They have benefits for themselves. I'd like to just point out. Yeah, we're going to dive into questions and the importance of questions. So, express in your point of view, 7, why it's so important to ask questions and what kind of questions are best to ask.
Oh, I love it. All right, so one of the mistakes that I made as a reliability engineer over my time is that I didn't ask questions. Now, what do you mean by that? You're probably going, geez, everyone asks questions. Well, that's true. Everyone does ask questions. It's to what degree of the questions that you need to think about in this case. All right. So businesses or large industries, large industrial industries can be, in my experience, somewhat proceduralized, i.e. that's the way that we've always done it type things. This is how what the procedure says we should do. This is what we have always done, as I've just mentioned, and that's where the problem starts. So a lot of the issues or problems that I've had in my career is where we haven't questioned what we're doing. Okay.
Mm-hmm.
So there was one extremely big failure that I was involved in, and we didn't question, or before I turned up, we didn't question how we actually efficated the repair. So the repair method of this particular thing was the same each time. And basically what had happened was that the problem kept on recurring because we didn't solve it through the repair method. So the machine had obviously failed. I'm just having a technical issue here, Dane. I think our screencasting's not doing us justice tonight.
Oh, right.
But anyway,
that's all right.
We'll onwards and upwards. And so the repair method wasn't questioned, okay? Or we didn't question different ways of doing things and avoiding not doing it, okay? Because the answer was too hard or too expensive. Okay, you know, and I know, and probably everyone listening to this podcast knows that technology is advancing at a rapid rate. Okay, it's advancing at a rapid rate.
Yes, very much so.
Okay, and there's new ways to do things. Okay, and every one of us has had a different experience, and each one brings a different experience level, or what would you say? Well, I'm just going to use different experience to the table. Okay.
Yep.
And so coming back to the original story, okay, it wasn't until I started questioning what we were doing, because after understanding habit 2 that this problem has occurred many times in the past, and all we are doing is exactly the same thing to fix it. Okay.
Yeah.
What I started asking the question, well, obviously what we're doing didn't work, so why do it? Okay, because all it's going to do is cause another problem it's just going to do the same thing. It's a matter of time because we haven't changed what we're doing. Okay. And it sort of comes down to, and I talk about in my book, Wayne Bissett, and I call it the Bissett framework. And it gives us a bit of a framework just to pose our questions. Okay. So I'm a mechanical engineer, but there's an equivalent to, I believe, in electrical land. But if you have a problem with a piece of equipment, right, or a piece of equipment stops functioning, okay, from a mechanical point of view, you will find the problem rooted. I'm going to use the word rooted in one of these areas. Okay, it's not running smooth, it's not running clean, it's not running cool, it's not running dry, it's incorrectly lubricated, or it's overloaded. So if you get all of those things right, all of those things, excuse my pencil there, if you get all of those things right, you've got a very high probability of getting that machine through to design life. Okay, so smooth, clean, cool, dry, correctly lubed, and not overloaded. If you can get all of those parameters right, okay, and it gives you a framework. If you think about it, it gives you a framework to actually question what's actually happening in your organisation. For example, if you've got water in your lubricants, all right, and water in your oils, like imagine if you had water in your transformer oil, like that's game over. That's like we're talking to boom type stuff. Yeah, your machine is not designed to run on water as a lubricant. You know, somebody will go, yes, some are. Okay, I've granted, some are. However, in the majority of
generally,
machines, generally, okay, if you have water in that machine, it's not going to end well, right? It's not going to end well because the machine won't get through to its design life, right? Why? Because effectively you've got a contaminant in there, and if it's designed to run on oil and you've got water in there, water cut hasn't got the same load capacity, it corrodes and all that sort of stuff. Okay, so in this big failure, what we actually found out was that the machine was not running smooth. The problem was that we didn't know that because no one had measured it. No one had measured it, right? It wasn't until I asked the question, like in this particular machine, I started asking, is this machine running smooth, clean, cool, dry, correctly lubed, or not overloaded? Well, operationally, the load was fixed. We couldn't change that, so strike that one out.
Yeah.
Correctly lubed. We went through the whole lubrication system piece by piece. We measured flows and pressures and changed filters and made sure the pumps were doing all the right things and everything like that. It was correctly lubed. There was no water in the system, right? So it was running dry. It was running quite cool. So we just went through and questioned all of these things. Got some data, and we'll talk about habit 4. Got some data on how things are running. Is it running to the right spec? Yes. We start ticking off the list. Then it was coming down to the smooth piece, and we didn't know. We didn't know. No one had measured it. Lo and behold, it wasn't running smooth. And you know, and this is a large industrial machine, and people would go, well, put your hand on it and figure that out. Yeah, but if you don't know what you don't know, and put a bit more science around it than putting your hand on it. All right. Okay. And essentially what we found out was the machine was misaligned. And we didn't know because we didn't measure it until somebody come along and questioned that, i.e. this little black duck, right? This person here. I would say we would have had more failures. Now, the interesting thing is that catching up with some of my friends down there, we sorted out that issue, and it was 10 years later, they had never had a failure the same since. And it was just, and that was totally born by this little black duck, i.e. me, starting to question what we're doing. Working through the BISSET framework at the time, right? BISSET framework, and ruling out all of these things and saying, right, it's got to be here. Now, some people say, oh, you should have like an RCA. It was sort of like a quasi RCA, but I used a framework to start me off.
Awesome. And it's so true. I think we need to ask questions. I think in life in general, we need to ask more questions and ask questions of what's working, what's not working, and maybe why. And you've got the classic RCA, which is the 5 whys. It's very short and simple, and we've talked about that in the past in other podcasts. Or you've got the full-blown sort of RCAs, or like you said, you can actually implement a quasi-RCA that is very technically based around why isn't this machine running? Why isn't this transformer operating correctly?
Yeah.
Or why did it go bang?
Yeah. And we figured out that it was misaligned, and then that's when the real RCA will have it to why? Why is it misaligned? Right?
Yeah.
So we started asking questions about that. We started asking questions of technical experts, right? How often should we check the alignment on this machine? And they started telling us information, and lo and behold, that information started to converge onto a consistent answer, right? You should be doing this, and that included like the OEM and other third parties on these particular machines. And we changed, and we changed stuff. We changed the way that we worked as a result of that. We ended up, the guys are telling me that there was periodic alignment checks, periodic vibration checks, all that sort of stuff on these machines. So we knew if a problem was starting to manifest for whatever reason. If we did this type of work on the machine, we realigned it. Like some people are going, duh, yeah, right. But again, we didn't put in the organisation. We didn't end up questioning those sort of things. This is the way that was always done. This is the way it was always done. Okay, and how to do things. Questioning how to do things, especially when your machine was designed in the 1950s and 1960s, where they didn't have the technology that we do now. Like, even though you got old stuff, right, doesn't mean that you can't get improvement from new technologies, even though you're not changing the nuts and bolts and components on the machines. There's a whole heap of technologies out there in the alignment space where, you can get lasers to go around corners, right? So if the machine wasn't designed to be laser aligned, well, that's okay. You can still get and there's an object in the road, you can still get a laser to go around a corner.
Still, exactly, yeah. And I think the critical thing is asking the questions enough and continue to ask more questions. If the question, I really like the way you pointed out the process of elimination. Like, you had your little steps, and it's like, okay, it's not, lubrication. We've checked all that. It's not. What was the first one? The
smooth,
output or
smooth, clean, cool, and dry. Yeah. Sorry.
It was clean.
Yep, clean. There was no water.
Clean, no water, dry. You went through the process.
Yeah,
not overloaded. That was one.
Yeah, because it was a fixed load. It was a fixed load. We couldn't change it. So, seeing that you're actually able to go through and cross off, and that's one of the things that we talk about in RCAs, is actually when you actually have a potential cause and a potential solution to those causes, is being able to cross them off. Being able to say, does this negate the focal point? Does this actually get evidence? Does the evidence support that this is actually going to fix a problem and we're not going to have, this failure? And so asking questions. And I think I always like to add that little HR element, human resource, reality, whatever you like to call it, sort of to it. And personally, I feel these days we hesitate to ask questions. I know some people will say, no, I don't have a problem with asking a question. I'll ask anyone anything. I think you'll find sometimes you might not. But even if you do, and even if you are, that's fantastic and that's great.
But sometimes, when you're in front of the maintenance manager, in front of the boss, or in front of the OEM, and you think that, you're going to get shot down for asking the silly question. I think that we need to sort of ask those silly questions sometimes. I like to kind of put it back in my term. I remember having debates with tradesmen when I was an apprentice or I don't know what you call them in the States. Anyway, a trainee, learning my trade. I'd ask a question and the tradesman say, "Oh, that's just how we do it." I'm like, well, okay, well, why? They're like, well, because you just do it. It's like, why? And what you start to realize is if you ask why enough and they keep giving you the same answer, they actually don't know. And when you look at a trade background, it's like you just said, it's like, this is what we've always done. Why? I don't know. We just have. And no one could answer it. So you had to go back to the mechanical basics and concepts and go, well, okay, let's just eliminate all these processes. And by, continuing to ask those questions and asking them of people, and if you ask with a compassionate mind and open mind, you're asking to actually find out and understand.
Yes.
And it's not being critical of other people. I think that's a really important point, as if you are a reliability engineer and you're listening to this, or as we've discussed, you're the maintenance manager, your job's to look after reliability and so forth. It's important that we do ask the questions, and we even bring it back to, let's pretend we don't know the machine at all. Let's pretend we don't know this plant. Let's go right back to basics and think of it. I once got told an analogy is that when you are trying to teach someone something, imagine you're teaching a 7-year-old. And the concept is that a 7-year-old generally understands basic English or basic language. Let's just use language. They understand good and bad, not good and bad. They understand, concepts, basic concepts. And if you can actually put it in a term that a 7-year-old can understand and go through the process and work out, like you can actually probably explain to a 7-year-old the basic concepts of an engine, right? And at that point in time, for that short period, they'll probably remember it and understand it and go, oh, okay, I get that. So if we put ourselves back in that sort of 7-year-old mind, or in my case, my 3-year-old asks me these questions all the time. But why, Dad? But why? Why? Why is the sky blue? I don't know. But if we then go, well, why is it going like that? Why is the fuel coming in here? Why does it matter if there's water in the fuel? What's the fuel quality like? Okay, it's good. It's, let's test it. Let's see. And then you get to eliminate the potential causes, or issues with such a thing. So, I think I certainly agree that asking questions and sort of going back to that basic mindset and being vulnerable enough and human enough to actually go, okay, let's pretend we don't know.
Yeah. Well, as the reliability engineers would probably agree with me, we are generalists. Okay, we're not a specific. We specialize in reliability. Yes, we're generally mechanical, electrical type people, but we are. I'm going to say we are generalists in the point of our technical knowledge about the machines. Okay, I used to work in a power station that had 17,000 plant items on it. They had people that specialised in the piece of equipment there on staff, right? If I wanted to go talk about the turbine, I go and see the turbine engineer, right? Because he was there. But when it came to solving problems inside that organisation, I was called on as the reliability engineer because and I was like what you just said. My task is to engage with those people and facilitate, and we'll talk about habit 5 later, and ask the dumb questions. And I'll say that when I'm facilitating an RCA, my role here is to ask the dumb questions. That's what I do, right? I don't understand this machine intimately like you people do. You guys
Yeah.
operate and maintain this thing every day. I don't.
Yeah.
I'm a third party person that you've called in to help. And
Yeah.
I'll ask the dumb questions, but there's a purpose behind that, because
Yeah.
not everyone in this room has had the same experience of this machine.
Yes. Yeah. And I think a really important thing I'd like to add to that, and I like the way you put that, is that in a lot of cases for reliability engineers, you do have people that know a machine a lot better. I'm traveling around here and around Australia, as we know and we've discussed. And the other day I was in a small town, very small town, and there just happened to be an Opal festival on that day. And we wandered around. I got chatting to an Opal miner. So this is where the miners have come, the cutters have come, and they're just digging it out. And I was actually blown away at the price of Opal, by the way. But I was talking to one of the guys that ran this property a few hundred Ks away. And he was like, yeah, I've got excavators, diggers, dozers, haul trucks, all this. He said, but I said, so who looks after, who maintains? He goes, I do all of it. I dig it out. I maintain the machines. I, fix the house and the electrics and do everything. Like, they don't have anyone to come out and do it. I said, how do you know when it's gone wrong? He said, I listen. And they are so intimate with their machines.
Yes.
He's like, and he actually found me up. He said, because we talked about big data analytics and other tools that we have. And he's like, can you help with hose failures? He said, because we're out in the middle of Australia. It's hot.
Yep.
It's dry. We get hose failures. It's like, well, that's a bit of a hard one, but if we get sensors on, blah, blah, blah. But the point was, he said he just knows by listening.
Yeah.
He's so attuned to the machine. And I think sometimes when, in my experience, when electrical engineers or mechanical engineers have been stepped in and asked to assess, review, or observe a particular machine or a piece of infrastructure that needs repairing, needs overhauling, needs fixing, in some cases, it's expected that the engineer knows everything about it or knows it very well. All right? Not necessarily. And one of the things I learned in my university times, and I thankfully already have, was the power of asking questions and actually finding out from the subject matter experts, which are sometimes actually the technicians on the floor, the guys that work with it all the time, the operators that drive it, that know that doesn't quite sound right. I drive around Australia in my bus.
Yes. Got a story, but I'll tell you that. You got your story.
Yeah. I got my little story. This is kind of fun.
Yeah.
So we drive around in a little bus. It was just a little community bus. And it has exhaust brakes. Now, I'm electrical. I understand enough to be dangerous in the bus and fix some stuff. Hopefully right, but sometimes not. But for the last couple of days, it was a little bit cooler in the morning, and it sounded like the exhaust brake was on. I'm like, I just started the bus and it's just idling. Why is the exhaust brake on? I'm like, this is really weird. But if I drive it along for a while, it goes away and it goes off. Like, what's going on? Racked my brain, thought about it for a little while, had a little look around, nothing obvious. And then I remembered that the girls, my little daughters, were playing around in the front seat, and there's an engine warming switch. So it has a little switch that in cold weather, you can heat the engine up as you start it, and it idles by turning the exhaust pressure back onto itself. So it applies the exhaust brake, right? Pumps heat back into the engine, and it heats up the engine so it warms up a little bit quicker. And that was what was setting it off. I was like, well, there you go.
They switched it on.
They switched it on. Like, I had hazard lights and everything going on. It was like, what is going on? It's like, oh, hang on. Oh, there's that one. It was just the one little button down by the side, out of the sort of way. It's like, oh, that's what it is. It went off. But it was like continually asking this sort of question, right? But I knew because of the sound I knew because I drive the bus that this wasn't normal.
Yep. Questioning.
And I started to question, like, why? What's the effect of this? Well, it's just applying a brake. If I push the clutch, it goes off. If I push the accelerator, it goes away. It's not really hurting anything because I run with them all the time. Okay, then let's think about it. So, yeah.
Oh,
So
very
what's your
good.
story?
My story is, and only I think you know this story, where we had a technical expert, right? A very, very technical expert actually understand and know the answer to this particular problem, but he couldn't get it across. He couldn't get it communicated to the rest of the crowd, right? And it's through it's through the questions that you ask as a part of an RCA that we actually got that message across to the rest of the people, and they all had an aha moment all at the same time and say, yes, that's the answer. but he actually
Yes, I do remember this story.
Yeah, and you probably remember the phone call when I said we had an aha moment.
I do.
And the interesting thing is that this guy actually, aside with no one around, actually thanked me for actually getting everyone across. Now they actually can see what he's trying to say. They actually, through that question,
Exactly.
they got understanding.
Yep.
Yeah, through those questions. Yeah,
Yep.
asking questions.
Yeah. And it's that balance of what I believe you call the hard and the soft side of engineering.
Yes.
It's having that, like, this particular subject matter expert was very hard and new, and this is it. Why are you wasting your time looking at this and probably getting frustrated?
Yeah, he
Because
was.
he's a subject matter expert, and he's like, no. But on the opposite side of that, here's the other team that are working. It's like, yeah, you're an expert, but it's not an ideal situation. And they'll make up a bunch of reasons and excuses and other opinions as to why it's not that.
Yep.
You know, because ours is just a little bit different, whatever. But like you said, by asking the questions and openly with a level of humility, you actually get everyone to come around.
Yes.
And it's very much, it's like, I've had a couple of knee operations, right? And anyone goes to a surgeon, especially orthopedic surgeon, they are the driest people in the world. It's like, no, this is what you got to do. We're going to cut you open, blah, blah, blah. And do it. Like, okay, fine. And it's the same sort of thing. Sometimes you get subject matter experts that are very hard engineered focused and information, very educated, very, on point with that. They can't communicate it properly. Yeah. And that's where a good reliability engineer can come around and ask the right questions and get the right piece of information. And even down to the technicians, that might be all the operators, for example, including them and getting them on board.
Absolutely.
And keeping everyone involved and asking the questions so that it is a collective response.
Yes.
It's a collective actually answering and moving it forward. So, yeah, I think asking questions are very critical and very important at leading you into what would you call the next habit, which is deciding with data. So when you ask the right questions, you get to gather as much evidence and data as you can to support potential solutions.
That's it. Awesome.
Well, I think we've nailed that one. I think that one's pretty nice and simple and to the point. I hope you have.
It's one of those habits that we have as reliability engineers. That we ask questions all the time.
Yeah.
That's how it works. Yeah. Well, that's what we do. We ask questions.
Yeah. Ask questions. Yeah. What's my job? I'm a reliability engineer. Oh, what do you do? Ask questions.
Yep, that's it.
No. Awesome. Well, thank you very much, Seven. To all you people out there, we appreciate you, and we appreciate your feedback, your comments, your thoughts. Smash the like button, subscribe, do whatever you do. Share this around with your friends and family, colleagues, anyone you think might be interested or might get a little bit of value. And yeah, we look forward to seeing you all again soon. And next up, we'll have habit 4, decide with data. So thank you again, Seven.
Thank you.
We'll see you next week.
No worries.